Curve is given by this equation, y equals x squared plus x. Actually, it's not too bad to sketch this quadratic because you can factorize it. It's going to have roots at 0 and -1. I know it's not essential to the question, but I'm going to illustrate what the normal then is. It's going to look like that. We want to find the equation of the normal when x is equal to 2. So a tangent when x equals 2 would look a little bit like this. It would just glance off of the curve. It would have the same gradient at that point. And then the normal is at right angles to that. So this is actually the equation that we want to find, this purple line. Okay, well, first up, I'm going to differentiate. I'm going to do dy by dx because that will give me the gradient everywhere along the curve y equals x squared plus x. And I'm going to get 2x plus 1. Bring the power down, reduce the power. The x, if you think about y equals mx plus c, the gradient of y equals x is just 1. So just get rid of it, the x. So when x equals 2, dy by dx is then going to equal 5. And this is also equal to the gradient of the tangent. They share the same gradient at that very point where they meet. I'm also going to find out the value of y. So that's going to be 2 squared plus 2 is going to be 6. So the normal is also going to go through that same point. But the gradient, because it's at right angles, it's a perpendicular line, we take the negative reciprocal of 5. It's going to be -1/5. And you've got two options. You can either use y equals mx plus c, or you can use y minus y1 is equal to mx minus x when you get to the same place. I'm using the latter, y minus 6 equals -1/5 times x minus 2. We're now asked to leave it in this form with a, b, and c integers. So I'm going to multiply it through by 5. 5y minus 30 is equal to minus x minus 2, which becomes minus x plus 2 when we expand the bracket. And finally, x plus 5y minus 32 is going to equal 0. And asked to find the values of k for which the line y equals kx minus 4 is a tangent to the curve. So I know that the y-intercept is -4. I'm still sticking with my accurate looking graph. And I want to get a tangent. So that means I'm potentially going to get a tangent here, but also here. So two possible values. Now the key thing about the tangent is that it just glances off of the curve. So I'm going to aim to solve these pair of simultaneous equations, and then I'm going to actually set the discriminant equal to 0 because it's not crossing in 2 places or 0 places, it's crossing in precisely 1 place. That's how we're going to deal with it. Okay, so x squared plus x will equal kx minus 4. Let's get it as a quadratic, so it's in the form ax squared plus bx plus c equals 0, because that's what you use the quadratic formula on. So I'm going to get plus x minus kx plus 4. It's going to equal 0. I just need to factorize the x out. So I'll put it on the right-hand side. It's going to be 1 minus k. That is my coefficient of x. This gives me a equal to 1, b equal to 1 minus k, and c equal to 4. So b squared minus 4ac equals 0 for the tangent. Um, equals 0. So I'm just going to say, actually, since one point of intersection. That means 1 minus k squared minus 4 times 1 times 4 will equal 0. Got a couple of options now. You can either expand this and solve the quadratic, but an even better way is to use, it's actually in completed square form. 1 minus k squared is then going to equal 16, and we can just take the square root directly from there. Plus or minus 4 when you take the square root. Don't forget the minus. Okay, I already showed you from the graph there's going to be two possible gradients, one negative and one positive. So that means minus k, I'm going to be minusing 1, so minus k is going to equal 3, or minus 5, which means k is going to equal minus 3 or 5.